Okay, gentlemen, today we're going to look at function compositions. Now, some of the classes of Mr. Hasselbauer's did this a little bit. Some classes saw this a pretty good amount. Others kind of didn't really touch on it. And I know, same for Mr. Fitz's class, where this was maybe briefly touched on, if any. We were kind of preparing for that test. So, just to get an intro to this, let's say you have these two functions. So you can either write this on a blank document in Notability, or I know for my guys, Mr. Hasselbauer guys, you can just kind of add this to the bottom of that 1.4 note sheet you have, and we kind of been working on that over the past, either you saw that on Monday or Tuesday, so we can just kind of work off the bottom of there. These are the same two problems we used for something else, so you can just work right from there. But if we're looking at this, so we had learned what this meant, f times g. And what that meant was you take the function f and you multiply it by the function g, which was pretty simple. You just take x squared minus 1 and you multiply it by radical x. Right? We saw that in class, and that was on our tests. And what you could do with this is, well, let's see if we can distribute. We can. I mean, it's not exactly the prettiest thing, but we can distribute. And this would become x squared radical x. Cannot be combined because you can't multiply into a radical. And then minus radical x, which again can't be combined at all. Obviously, that just stays. So you can leave it like that. You can leave it like it is on the left. But either way, that's about as simple as it gets. You multiply your two functions, f times g. And then you would find the domain of this, which, as we know, our domain would be from 0 to infinity, including the 0. Now, what we touched upon or didn't touch upon or are going to introduce now is the idea of, well, what happens if I want to take a function f, and instead of multiplying it or dividing it like we saw, or adding or subtracting, what if I want to take a function and I want to input into that function another function? So in our case, g. And this, let's say we would do it of x, right? So you're inputting into the function f the function g, which may be a little hard to comprehend. So let's start it with the idea of, let's say we just try it with a number 9. So I'm saying x is 9, and what I want to do is take my function g to start. G, we know, is radical x, right? But now what I'm asking, say, is, well, solve g for the x value 9. So take g, plug in 9, and solve. Okay, so obviously pretty simple here. We can see that that's just, keep the colors the same, that's just a 3. Okay, so that's the inside. We're working inside out, where I say f of g of 9. G of x, do that with 9, I got 3. Take that 3, and that is my new input to f. So now we get this wacky game we're playing here with what's the domain of g, and then we have to take into account, well, what is like my range of g, like what comes out of g, what is the results of g, and those are my domain, that becomes my domain of f. So it's like this inception double layer stuff. Okay, so we'll do a couple examples, and then with numbers, and then we'll do it with variables, and then we'll start to talk about domain in class. But it goes from g, domain, that result is my new domain, so this double layer stuff. But anyway, here's my x squared minus 1, there's f. I'm taking what I got from g, and I'm plugging that in to my function, and I'm getting 8. Okay, so I got 8. But obviously, would you prefer to do this, side note it, plug it in, and then do it again? There's got to be a quicker way. And if there is, what is that way? Well, I don't want to say I got to try it for every number. Is there a general formula I can do? So kind of what we started with is, can I do this for any given x? Well, let's see. Well, what did I do? Well, really, I took g, and I plugged in a number, but I took this function, and that function's coming out with a number that's getting plugged in. So what happens if I just plug in my whole function as my x? That's really what I do here. I take g of 9, here's my function. Everywhere I see an x, I write 9. Everywhere I see an x, I write 9. Well, what happens if I just say everywhere I see an x, I'm going to put g of x. And g of x is radical x. I'm going to plug that in. If we do this, we can see, well, square root squared, that's just x minus 1. How nice. It's a pretty simple, brand new equation I got here. Well, interestingly enough, if I take f of g of 9 and I plug it into this guy I just found, I get 9 minus 1, which is 8. And would you look at that? They're the same. So you could either find your generalized formula plugging in g of x into f, simplifying, and then say, now I'm going to plug my 9 into that composition, solve 8. Or take this, plug it into g, get a result, plug that into f, get a result. Obviously, this is preferred in the realm of math. Okay? And now we have this, like I said, we have this idea with domain. Well, we don't really want to take the domain here. We got to take the domain based on what we started with. So we'll graph this at the end if we have time. Okay, but now let's kind of reverse it. So let's say g was the outside function, and I had g of f of x, and I'll make the x 9 again. We'll do the same thing. Okay, so my f function is x squared minus 1. What happens if that's 9? What if I have 9? What would I get as a result with 9? Well, I see here, I would get 81 minus 1, I'd get 80. So f of 9 is 80. I'm going to plug in 80 as my new input for g, because that was my result of f. And I'm going to solve that. So I'm going to plug into g, which is radical x, you can kind of see at the top, the 80 that I got from plugging in 9 to f. Obviously, I would simplify this if I can, which we definitely can, for radical 5. Okay, I'm going to get a decimal for this. For radical 5, 8.944. 8.944, and I'm going to get that just to look at it later. Okay, well, again, let's say I want to generalize it. So I know I get 8.944. Well, let's see what happens if I kind of generalize it like we did up here. So instead of saying I'm going to plug in 9 to f, get a result, then plug that into g, let's work to get our generalized composition, which would be solve it with x, plug it in, see what we get, and then go from there. Okay? Okay, so I got f of x, and I'm going to plug that into everywhere I see an x in g. Well, there's g, it's just radical x. And I'm going to take f and plug it in everywhere I saw an x. So here was g, there's 1x, and that whole x is going to become x squared minus 1. There it is. Here's g, the outside function. Everywhere I see an x, I'm going to write f, which is x squared minus 1. Okay? Now, just as we learned with radicals, I can't split up a radical unless this was multiplication, because it's not. I can't square root part of it and take this out. I got to do it to the whole thing, which I can't break up because that's a minus sign. So I can't do anything here. That's essentially the combined composition function. But if I were to take that and say, well, let's do our f or g of f of 9 and see if we get the same thing. Well, if I do that, I would get, and I'll try to keep the colors the same, 9 squared minus 1. And that would give me radical 81 minus 1, which is radical 80, which clearly is, whoops, the same. There they are, the same. Right? So we're playing with this game of finding a composition where I'm composing, meaning putting G as the input to F, or putting F as the input to G. And they are different functions. Look at this, totally different than this, simplified. I get the same answer for both versions of F of G of 9 and F of G of 9, obviously. But G on the outside or F on the outside, I'm getting totally different answers and totally different functions. So they are different functions. If you compose them inside each other, you get different things, just like when we did divide. Okay? So if we have time, we'll graph this at the end, but let's look at another example. Let's look at these two, and I'll just do the F of G of X, and then we'll just do the other way around. I won't plug in a number to save a little bit of time, but let's see here. And we'll start to think about domain. What would the domain be? Because we're doing domain, getting a result, and then using that result as our new domain. So it gets kind of tricky. Okay, so here's G as the inside. G is the inside. So I'm going to take F. There's F. And I want to put G of X, which is this, everywhere I see an X up here. I'm going to put G of X everywhere I see an X up here. So here's an X. I'm going to replace that X with G of X. Everywhere I see an X in F, I'm going to replace that with G of X. There it is. Similar to up above, this cannot be simplified at all, sadly, because it's a plus sign, so I cannot split up the radical, right? This is not radical x squared plus radical 2, no. And I can't, so since I can't do that, I can't simplify it at all. There's nothing I can do with it. I can't factor it, no, nothing, that's it. So there's my answer for F of G of X. Okay, and if I were to plug in a number, I would get the answer the same as if I were to do G of X first, get that answer, and then plug it into F. Okay, let's do the other way around. What happens if I take G, and that's the outside function, and F is the inside function? So I'm taking G, which is X squared. That's the outside function. And I'm going to plug F, which is this, everywhere I see an X in G. So there's an X. And I'm going to replace that with X plus 2. A little cramp there, but X plus 2. Right? And as you saw what I did, I took the X out, put a parentheses, and replaced it with exactly what F of X is. That gets put in as a replacement of that X. We know squaring a square root will yield us just the X plus 2, just the inside, the radicand, if you will. Here is my simplified G of F of X. There it is. And actually, a very simple equation. This would be much easier than doing F of X and plugging it in. This is much, much, much easier. Okay? And remember, we're going to start to think about what our domains would be for these, And that's what we're going to think about in class next time I see you guys. Okay, so good luck. Take a look at this. You have a couple problems for homework, so practice those. Okay? Good luck.